Talked about specifically about how actually certain trials can actually be observed as an experiment, whether they're random or not, based upon two things, whether it's success or failure. Okay? Now, that was the biggest thing that he talked about. Now, I do put Sammy in here and everything else because I have to give him credit because he wrote the notes. So, sometimes I'll say BD or Bernoulli or binomial distribution. You guys are familiar with the binomial theorem, Pascal's triangle, everything else, N choose R, etc. Well, he used that and applied that to his new formula, which is called the Bernoulli principle or Bernoulli formula. This is where an experiment it has two possible outcomes. Either you win or you lose. Either it's success or failure. Okay? That's the hard fact, right? You're back like I was in Korea, Sophia. That's how they teach the Koreans. Either you got it or you didn't. There's no partial credit, nothing. All they do, guys, is, and I'll do it myself sometimes, I look at the answer, and if the answer's right, I know it. Then I look for, the sandwich stuff in between. But if it's not there, then I hunt. But a typical person from Asia that's grading and so on, boom, that answer isn't there, they stop. They just say, you're wrong. Okay? That's what they'll say. Gotcha, you're wrong. So the biggest thing is here, oh, there it is. Is a couple of experiments here, such as flipping a coin X amount of times, N amount of times, right? Heads or tails. We decide whether the heads, everybody likes to be heads up, right? So heads we can determine as a success, or tails as a failure, right? Now, when I would be in football and they would say heads or tails, I would always have this big linebacker, because I was a tailback, because I was short, and everything else. And I was quick. I wasn't fast. I was quick. And he would say, "Don't say anything." Just you give me this big scowl. He's like this tall. Right? Don't you dare say anything. Right? I just remember that. It's fine. Okay. Okay. So another one would be an election poll. For example, like you're interested in two types of candidates. Well, I'm not going to get into politics, but candidate A or candidate B. What's the chance of Sammy winning over the loser? Right, the person that's not going to win. Sammy's running for president. Okay, he should.
Sammy gets my vote.
Sammy has no choice, right? And the next one is a production line. And I'm very familiar with this, that you're finding out how many times you can find. Now, you determine what success or failure, right? Success could be, as an example, finding out failure, right? How many defective parts I can get. That would be a success in this example. All right? So I would say the random variable would be either 1 or 0, success or failure. I don't have to copy all this stuff. Relax, all right? I'm just using this example. So this would be your y and your x, so to speak, y and f of x. So with that said, the trials are between 0 and 1, yes? So it would be a denomination between any range or domain, I should say domain, of between 0 and 1. All those decimals and radical numbers, everything else between 0 and 1. So if I said, head is the success and tail is the failure, what's the probability of flipping a coin to get a head on the first flip? 50%. And that decimal is? 0.5. So P would be what? 0.5. And Q, or 1 minus P, would be what?
0.5.
0.5. Success determines the other by failure, or vice versa. Right? No big deal. It's always off 100%. Yeah? All right? So that's why I'm subtracting this, where P is a success. Don't worry about this. Come over here. You already know the N choose R, right?
Yes.
No big deal?
Yeah.
Now, this is just an example, okay? I'm going right into my college zone, okay? Just what I've been doing all forever. So this would be a good multiple guess test, right? So you have 4 questions, whatever they are, and they have 4 choices, 4 possible answers, A, B, C, D, right? Okay? Whatever they are, A, B, C, D. And you have a total of 5 questions. Not bad? Sound familiar? Yeah? And I said, I used Y because it was in my notes. You could use X, right? No big deal for the random. And I said, let Y equal the number of correct choices. So that's no correct choices, 1, 2, 3, 4, and then of course 5's 100, right? You got them all right. You're just randomly guessing. Like you got this SAT thing, and you see those kids, they always try to make, funny looking shape or whatever it is, and they're trying to guess. That's all they're doing is guessing, or they're bored and then they do such a thing. Well, let's say that what that individual's doing. So what would be the chance of that person doing all that stuff? Well, to get 0 correct, you're going to use 5 choose 0, all right, N choose R, or the C, okay? And the first success would be what? P would be 0.25, right? And then you subtract that from 100%, and that would be the failure rate. Make sense? Not bad. It's okay so far? Yes, ma'am.
I should get 0.25.
2.5. Why did I get 2.5? Help this lady out. Nick and then.
4 possible answers.
That's right. 4 possible choices, man.
Only one can be correct.
Only one could be correct, okay? So 1 out of 4, 25%. Okay, good job. Yeah. It's great to ask. That means everybody else said thank you. Okay? Nick? No.
For the n choose R formula, what, in the denominator, what's the first thing?
That's that R. It's just a funny looking R. Okay. R factorial. Nick?
And the reason why it's 0.25 to the 0th and 0.75 to the 5th is that your 1/4 of them is not correct.
1/4 to the 0, right? Because you have no possibility, right? Nothing's
I
correct.
think that's the odds of getting none of them.
None of them correct. Correct. Yeah. Yes. Hence, because I said, look at, let the Y be the number of correct answers. Not bad? Now I keep going on, and I could fill those boxes up if you want, whatever they are. Doesn't mean it. You don't have to. I just did this as an example. This would be some decimal. This is going to be some decimal. Yes? Some decimal chance to probability, right? Probability of happening. So F choose 1 is the probability when Y equals 1. It means exactly when it equals 1. I didn't say less than or greater than, right? Because if I said less than, I got to consider all the other possibilities. Remember? All right, good. So this one would be, hey, 1 possibility, 5 choose 1, right? 0.25, and then 0.75. And then we keep going on and on and on. When you add all these up, you should get 1, right? If you add up all these boxes, like an expected value deal, you'll get 1.
Yes.
Yeah.
Now, I just did that as an example. Okay? That's all I did. I did a whole bunch of it. So the formula for the overall Bernoulli, or BD, is this one right here. And it mirrors exactly what's in the notes that I gave you. Okay? Pretty good? You can, yes, ma'am.
For the second one, y equals 1, are the exponents correct?
5 choose 1. 5 and 1. Good job. Good. That's why you're going to be a Chem E. 5 choose 1, 5 choose 2, 5 and, well, it'll be 5 and 0, right?
1 and 4.
1 choose 5.
1 choose 5.
Or 1 choose 4, I'm
So
sorry.
wouldn't it be 1 and 4?
4 and 1?
You set it up.
1, 4.
Is it 1 and 4?
Yeah.
I counted real fast. 1 and 4. 1 and 4, then I should have 4 and 1. Then I have 4 and 1 right there. But,
Yeah.
okay. I'm not worried about it. I just did it real fast to show you the progression. That's it. Okay? Now, let's do one together. All right? I know it's right because I checked with the person in UNM 12 years ago. All right? Yeah. Okay, so, big thing here, right? Sometimes, guys, you write this out. Remember it was N with a little subscript for normal distribution? And they had just like an N here and then N and sigma, or sigma, what is it? N and sigma? They had it that way?
Squared?
Yeah, well, sigma's not squared, that's variance.
No,
Just
yeah,
sigma.
sorry.
It would be mu and sigma. Mu and
Yeah.
sigma, right? For
Thinking of
trial
something
straight.
else.
You're right. Yeah, that's a little later. And I put this as y, it could be x. This just says bin for binomial distribution. All right? Just so you know the nomenclature. All right, so let's say Sam examines 10 items. All right? 10 items, and he wants to know which one are the defective items and wants to find out, big deal here, which are one or fewer. All right, let him copy that one. Okay? Not you.
The probability that x is less than or equal to 1.
Got it. Hold on. You're right. You're right. Let him copy this down, right? Now, I wrote this. You don't have to write this. I just did it because I was in my 400 level stat class. Okay? So, if you don't, that's okay. Well, why don't I start off with a formula, right? Would that help? Yeah. Well, probability. Yeah. And Mr. Appler told us, right? Because it says 1 or fewer, right? And I used X or Y, it doesn't matter what variable. And it said 1 or fewer. What goes here? This
Less than or equal to.
excellent. To what?
1.
1. So, for that to happen, it's always integer numbers, right? Because there's only 1 chance, 2 chance, X, that's it. Right? Now, we're not doing negative distribution. Negative binomial distribution. That's another matter. That's for my other class later on at home, okay? So this is what you start off with, right? So
Yep.
that means it breaks down into 2 possibilities. What are those 2 possibilities for probability? Yes, sir? And
0
yes.
broken and 1 are broken, and you add them together.
P, where X equals 0, as well as, right? P, when X equals 1. right? Both of those possibilities. So Sam's going around, and it says 1 or fewer. Well, that means there's no defective parts in a combination thereof with one defective part, or whatever it is. Cool? Yes? No? We're okay? Yep, yep. Billy?
I'm
Oh,
just reading.
okay.
Good.
It's the morning, right?
Yeah, I know. Can we move the,
Question mark?
no, the string. The
So-
string?
String.
Goes right through the
Yeah, I know. All right. Good. Sure can come right out. So, can someone tell me what P of 0 is going to be? I'll give you a hint. There you go. What's 0? How many parts? Remember, this is N choose R, N choose P, whatever.
Choose 0.
N, so what's the N?
10.
Good job. 10 choose 0 of,
Success rate.
and the success rate was initiated by, I should have wrote that down, right?
Yeah, how do we know the success rate?
Because I gave it to you right there.
Oh,
So that's given.
included in the problem?
Yes, sir.
Okay.
Okay.
Has to be.
I was
Has to.
so confused.
Are you like, what are you doing?
I was like-
Remember, I was copying real fast, right? Yeah.
Okay.
And choose zeros.
So it's going to be what? 0.02
To the 0th.
to the 0 times what, everybody?
0.98 to the 10th.
Excellent.
Okay.
0.98 to the 10th. Is that okay?
So all failed, no success.
That's correct. Perfect way to say it. Even though they're defective, right? That's still a fail, even though it's defective. I know it's counterintuitive in English, but that's what it really means. That's why math is the greater of all languages. Plus, Sammy comes around and now he finds a boo-boo. 10 choose 1, because there's still 10 possibilities, right?
Yeah.
That's still the same. The bases are still going to be the same, right? She's like, yeah, good. I missed teaching this class. All right, what's next?
To the first power.
First power. And you always take this guy and subtract from the big guy, right?
Yeah.
And then you got 0.98 to the?
9th.
Outstanding. Huh?
I remember this.
Pretty good? Not bad? Fair? Now, just to show you what these values equal, you calculator crunch it out. It should be this way. Go to 4 places. I think Sammy got 0.8171 for the first guy, okay? You guys got more room, okay? Is that all right? So then the next thing is the next guy would be 0.1667. You add these two decimals up, and you would get 0. Someone's going to beat me to it, maybe? 99% chance of finding 1 or fewer defects.
Mr. Murmer?
That's me, and then yeah.
Like, let's say if they wanted 2 or more, what you would do is 1 or fewer and then do 1 minus that because you'd be doing a lot of work if you did 2 or more.
Right,
Yes.
right. Yes, you would be, Caitlin.
So the reason we stopped it to like the 0.02 to the 1 is because it said 1 or fewer.
Yes,
Okay.
because they're going to consider 1 and 0.
1 and 2. Okay.
Good job. All right, not bad. It's okay if I wrote all this insanity out? I was going to do expected value and mean, but Sophia said no. Okay? And you said don't you dare. All right? So I'll throw my snake at you. All right? So, because I wanted to prove to you about how expectation happens and mean and the variance. And I just was like salivating, but like, no. Yes?
Do they ever have trigonometric functions
Yes.
within the binomial
Yes.
distribution?
Yes.
That'd be crazy.
Yes. No, it's not. How is that crazy? Yes.
You have this amazing.
Can you what? Your normal distribution page is right here. Boom. I hope you read it because it really sets up everything. All right. I would do the. I gave you all the answers too, so you can't go. Well, I don't know what to do. Okay. Yes.
I'll do that anyways.
Right. So let's talk about. Let's do one binomial distribution that is. Let's say I think it's on the practice, right? On this sheet right here, and then we'll do the worksheet, so to speak. We'll do 1 or 2 on it. Is that okay? I wish I got to erase. That's okay. I'll erase right here.
So which one are we doing?
We're going to do, you guys are going to pick it out.
From the notes?
You want to do number 7? It's under
No,
the, we can do some of that. Don't worry, we will. We're going to do that.
It's on page 7.
Oh, it's on page 7. Thank you.
Do number 1.
Do number 1? Okay. So it's page 7 on the notes. Okay. Yes, ma'am. Oh, yes, we do, yes. So I make 10 billion notes. Forest industry, they claim only 5% of the old sawmill sites have soil residue of dioxin. Oh, Sammy loves dioxin. It's bad stuff. It's bad stuff. That just kills all plant life and everything. All right, so all of this stuff right here, right? Let's see, make sure I have it. So they want us to calculate the prop. So if there's 20 sawmills and 5%, right? So far, so good? Mm-hmm. They want us to figure out A. It says calculate the probability that less than 1 will exceed the recommended dioxin level.
Probability of 0 plus probability.
Right. Let's talk about what we have. What is N? Let's start listing what we have.
The number of trials.
And that would be how many sawmills, right?
20.
20. Now, what is the probability of the success rate that we construe from this problem?
0.05.
And where did you get that from?
5%.
Right, because it claims, I claim that there's only 5%. P is 0.05. Now, 1 minus P, I'm going to use Q. Is that okay?
Yep.
It's the same thing.
Yes.
It's okay? And that would be,
0.95.
this is success, this is fail. Yes?
Yep.
Cool? How are we doing? Remember, calculate the probability that less than 1. What is less than 1?
Not including 1.
Not including
Just 0.
so good and good. Yes. So I'm doing the probability. This said less than 1. Remember, it can only be integers, right? It can only be integers. So x equals 0. Because that's the only thing less than 1, right?
Yeah.
Yeah. Now, if I said less than 10, then I got to do I would go P less than 10 or whatever, right? I can do it that way if I wanted to. Now we just plug in the stuff, right? Pardon me?
Couldn't you just say like 0 sawmills instead of less than 1?
Yeah?
It's not fun.
But it doesn't sound right, right? Yeah, you could. Yes, you could.
They have to
Or they would say it this way. He's right. How about, that's not found in any sawmills. Right? Any
Not to make
sawmills.
it difficult.
Yeah.
Make sure you're paying attention.
Wow, math and attention, I don't know. So, what's the N choose what here? What's it going to be?
20 choose 0.
20 choose 0, right? Yeah. 20 choose 0 of?
0.05 to the 0th. Because no successes.
Excellent. And then next
All
one?
failures. So 0.95 to the 20th.
Cool. Bang that out. It has the answer right there, right? So 0.3585, roughly 36%. What does that mean now, mathematicians?
So there's a 36% chance that none of them will have the poison.
Yeah.
We'll have what?
Say that again. You said it.
There's a 36% chance that none of the sawmills will test for dioxin.
Calculate the probability that less than not, so no chance of the recommended levels of dioxin. Yes. Right? So you walk around, 36% chance. None of these guys are going to have it. That's what it says. Cool. We okay? Pardon me? Sawmills are they just destroy the environment, right? Now notice for B, right? B says what? Less than or equal to 1. Ooh. So it's really just being what then? Can I just go to B? Is that okay?
Well, you can just take the percentage from the
And
previous
then add it
one.
to whatever.
Because there's 0 and 1, right? Because it says less than or equal to 1. A lot of people are like, oh, I didn't need this, right? But you guys are too smart. Like, we know that. So it's this guy plus probability when x equals 1. Now, would you be wrong if you said probability is less than or equal to 1? No, you wouldn't. Very good, right? But you must consider both of those conditions. So can anybody set this one up? So it's going to be N choose what?
20 choose 1.
20 choose 1 of?
0.05 to the 1st.
And then also?
0.95 to the 9th.
And I guess Nick is right, and so is Rob. Thank you, hon, thank you. Keep me honest. I used to work for the government.
Wait, isn't it 20? So wouldn't it be 19?
Pardon me?
Wouldn't it be 19 instead of 9?
19? No.
Oh, where do you
Because
say?
if you said 19, right, that means you're only choosing 19 of those sawmills. You excluded one, right? Right?
Wait, no. I was thinking there was 10.
Only the X on it.
So, yeah, I'm talking
Oh,
should be
1 and
19.
19.
Yeah.
Oh, 19. There we go. Okay. 1 and 19 is 20. Thank you. I thought she meant the base.
Weren't you in the military?
Yes. I've been around. Okay, so letter C.
Were you a nuclear
Letter C.
physicist?
I've done many things. Good, bad, and indifferent. All for the country, all for king and country. All right? Yes? That's a very fancy way of saying it.
British flag.
British one. Fairlex, right? So the next one would be what? Calculate the probability that at most, or a maximum of 2 sites. So it'd just be,
They should have an answer to be into it.
yes, the answers are right here. Yes, yes, I gave them to you. I gave you everything. You never come to me and cry about it. Don't cry to me,
So
Argentina.
now we just do less than
Oh my god.
Yes.
Crying this time.
Less than or equal to 2, which means 1, 0, 1, 2, right?
So we just add those and then 2.
And then 2, right? Probability when x equals 2. So for the last one, it's going to be the probability of 0 plus probability of 1, probability of 2, which is P. All of this is, Miss Caitlin is right, probability when x is less than or equal to 2, less than or equal to 2. Is that better? Yeah. Cool? We doing okay? Yeah.
Yeah.
How much time is Bear? My timekeeper. She's like, I don't know. I just go to school here. 15. Good.
We get out at 29.
Oh, we need more time. Okay. Not
I
bad.
studied this class before.
That wasn't bad, right? Do you think I might pop one of them on there?
Yeah.
Just change the numbers,
Please,
whatever.
please, I'm really good at binomial distribution.
Yeah.
Okay. Now what they do is they combine them, right? They do the normal, and then you take the information from the normal and apply it to the binomial. Okay? Oh, it sucks. I hate it. Okay. We're going to do one together where they combine all this madness. Method to the madness. Okay? Yes? Oh. So let me get my stuff squared away here. All right.
I wish I understood the. See, I understand binomial distribution. but
Yes, yes.
This chart,
Yeah.
for some reason, I just can't like wrap my head around the fact that we don't have the negatives.
I made copies. I know. I made
but
copies.
we can't use those copies on our final.
Oh, really? That means they won't give them. They won't give you anything less than, right? Oh, but you have to subtract, right?
Yeah.
You have to. That's stupid. Just give them the
It
values.
just
All right.
goes over my head for some reason. I understand it. I
Yeah,
just don't
same.
know when to use it.
All right. Let's apply. Now let's do the 1-2 punch, right? You got the fastball down. Let's see if you get the slider. Okay. Baseball, Yankees. Okay. All right. So let's take a look at number. Oh, that's too easy. All right. Let's go to number 3. Numero 3. It says winner for me. All right. I need Mr. Radio Voice, Noah. Read number 3, Noah.
The probability that a driver must stop at any one traffic light coming to Lincoln University is 0.2. There are 15 sets of traffic lights on the journey.
Keep going. Okay. So.
Oh, okay.
All right. That's it, right? Okay.
Yeah.
So probability of stopping is 0.2. And then
All right. Let's list what we got, right?
15 lights and 0.2.
Right. So we're doing number 3, right?
Yeah.
Okay, so the mean of a certain thing is 4 times. No, that's 4. 3. The random variable is it the daily profit guy? Yes. So we have the mean, which is what?
Wait, that's not it.
No. Number 3, right? Did I say number 3?
Yeah.
Probability of driving to stop, yeah.
Why is mine different than yours?
Is that a Y?
Mine's different too.
Mine says the random variable
Right here.
x of daily
The
profit.
notes.
No.
Is
I'm doing this one, sir.
That
I'm
number.
sorry. I meant to do the worksheet. Let's call this the drill and kill worksheet. Okay. Sorry. I did one already on the practice. Okay.
Yeah, I'll agree with that one.
Thank you. That's my fault. My fault. I'm just going too fast. I don't need to.
I totally just wrote that down on the
All
sheet.
right. Number 3, call this drill and kill. Okay?
The random
There we go.
variable X is the daily profit in thousands of dollars made by a company. X is normally distributed with mean 6.4 and standard deviation 5.2.
Okay, good. Means what?
6.4.
Standard deviation's what?
5.2.
Everything's in thousands of dollars, like you said. Little I guy. Go ahead, Noah. Find what?
Find the probability that on a randomly chosen day the company makes a profit between $10,000 and $12,000.
Now, it's $10,000 and $12,000, right?
Mm-hmm.
So it's 10 and 12, right?
Yeah.
So we need to do what first?
Need to find their Z.
Yes.
Yeah. So
Yes.
don't we need to set up the normal curve and then find the corresponding z-scores?
Yes, we won't even need to do the curve. Okay? Well, first thing I'm going to write z equals what? X minus what?
X minus mu
X
over
minus
sigma?
mu over sigma.
Yep.
So let's call the first one z of what? 12. What do you want to do? $12,000 one or $10,000 one? let's do Z of 12K. Is
Okay.
that okay? Z of $12,000?
Yeah.
Now, everything's in thousands, right? So if you do a 12,000, that's a pretty small mean compared to it, right? So you knock off the thousands. So it's really just Z of, the random variable is going to be 12. Because it said it's in thousands of dollars.
Yeah.
Okay.
Good?
Yeah.
Because it wouldn't make sense. You're going to have a huge thing, you're not going to find nothing on there. So this X variable becomes now what?
So 12 minus 6.4
12 minus 6.4.
over 5.2.
Right? Anybody want to tell me what that is? Call that Z of 1 or Z of 12, I don't care.
Wait, why are you able to lock off the?
One
Because
point.
it said in thousands of dollars.
You're not gonna find the thousand.
Because if you put 12,000 minus 6, you're going to be like, what the? It's not
It's
Wednesday,
gonna be
Thursday,
huge.
Friday, right?
Yeah.
You know it. Okay, they did that on purpose. Don't look at me, I didn't write it.
The Z is about
1.08.
point zero.
1 point something. 1.077?
Yeah,
Good enough for me.
that's a good one.
Not just for 12, you're going to do it for also 10. Z of 10K. And that's going to be 10 minus what?
6.4.
Over.
5.8.
And I heard it. Try again. It's a little more or less, right? That's okay.
What is the answer? 0.692.
2.
Yep.
0.692?
Yeah.
Okay. Now,
Shouldn't we go to the fourth decimal just
you could if you want.
What does the Z table have? It only goes out to
4 decimals?
4 decimals, so.
Yeah, that's fine. And you can use 4 decimals, okay? All right? So, we need to find the phi difference, right? Because it said in the problem, number 3, I'm trying to get it here. The company makes between. So if you had a graph, right?
Yeah.
You got your Z1, not the scale, and your Z2, right? So they want to find all that stuff. Cool? Right? So what do? We look them up.
You find the probability of less than Z2, which
So
is the case.
phi of Z1 minus phi of Z2, right? Can
What is
someone
that?
tell me what the first, let's call that the first one. The 1.70, whatever. And could you tell me that value? 1. Yes, sir.
What is phi?
Phi is, they use that to find out what the value is for Z.
That looks Scandinavian.
It's not, well, it's Greek, but Scandinavians have borrowed that.
How do you do the Z table?
Okay, so, okay, so, you have a Z score, right?
Yes.
And so you gotta look up what, 1.70?
Do you look in the chart or on the
Well,
outside?
1.7.
You have the,
We have the additional.
good question, okay, hold on, let me answer the question and
1.077.
everything. So, someone tell me, I don't know what to do. How do I get the value? I'm looking for a probability, right?
Yeah.
Yeah.
All this, ma'am, is the probabilities that I'm looking for.
We have
I have the Z score. I have the Z score, not the other way around, right?
Yeah.
Can someone tell me what it is?
1.07.
Okay, so you go here, ma'am. 1.07,
All the way over to 7.
and what'd you get? Roughly.
Then we can add.
0.8577, and then we
Oh,
have
stop there, shh.
8577.
Did you see that, Miss B?
Yeah.
Of course you did.
And now,
Whatever it
because
is, right?
We go to the,
They got something a little different, but it's really close, okay?
Can we add the thing?
Because they
yeah,
probably have
we
more
add
approximation.
16 for the other 7.
And now what's the other guy? Then you go what? You look at 0.6, what is it, 0.69? So you look at 0.69, you go to 0.6 and you go across, right? All the way to 9? Because that's how you read it?
Mr.
Ms.
Mur-
B? Hold on, let me look at it and then I'll answer your question.
Yeah.
And what'd you get? What's it roughly?
0.7549.
7549? Does everybody agree? Yes, no?
Yeah.
They have it a little different, but it's really close. It's off only by a couple. So we get
Okay.
roughly what?
We would.
The reason why they have different numbers is because they went to the third,
Yeah, they went.
1.077,
Right.
and we have additional
This is our Cambridge chart.
add-ons.
The way they do it here is they have additional add-ons, so the decimal actually goes
Okay.
out to the.
Okay.
And that's,
That's the
for
addition.
So you just add it on to the
Yeah,
end.
add this on.
All right, I'm not that.
So you add on.
Oh, hold on. And then I'll get you stuff here.
so,
Okay? Ask
you have the 0.8577, then you're gonna add
16.
Add
Subtract.
16 to
Oh,
add.
the 16?
So you add
Oh,
point
okay.
0016.
Yeah.
Okay.
Yeah,
Or you
so
can just write 8577 plus 16
Okay.
instead
Yeah.
of having to write the decimal.
they have for the first value, hold on, Sophia, 0.8593.
Oh, okay, yeah.
That's what they have.
Yeah, that's what we have.
That's what you have, okay. I didn't use that additional, okay? They're more exact. They're just more, really more precise. Sophia?
I'm still confused how we're finding those numbers.
Okay. Ryan?
You want me to?
Yes. She'll learn 100 times faster than me.
Uh,
Go run over there and show her. Go.
Yeah.
If you wouldn't mind. You don't care. I want to know. Good. I love that. The next one is going to be what? Point. If I can find it. 0.7556, right?
Yeah.
I mean, I was only out by a few thousandths.
Yeah.
Big deal. And then roughly, I'll stop here. Not I won't, but 0.104. Is everybody okay on that one? Bella, all right? And it's like, yeah, keep going. Shut up, just keep going. Or just stop talking about whatever. All right? So far, so good?
Yes.
All right, that's the first count. So it's 10% chance, right?
So do we subtract or something?
Yeah, because it said between.
Yeah.
Between. Big guy minus small guy, right?
Yeah.
Okay? Okay, that's a good question.
We got 10.37%.
Yes.
Yeah, whatever it is. They went 0.104, which is 1.0. You get the 0.1037 you probably got. Okay, and they went 104. All right, that's good. Now, everybody okay on that one?
Mr. Murmer?
All right, yes.
So where did you get those exact numbers from, the .8593?
We got them from the Cambridge table. That's the only difference.
Okay, so the Cambridge table only gives us to second decimal, right? But we have third decimal
And it says add
things,
to.
and so we have the 1 through 9, the add. You
Okay.
add that, you tack that onto the end of the decimal.
Right.
So we
Mine
have
is,
Yeah.
the 8577. It gives a 1.077. The last 7 would be 16. You'd add 16 to the end of 8577. So you're adding 0.0016.
But when you have, like, for example, 1.0 and then you go to .07, wouldn't it be 1.007? But we don't want that. We want 1.
Oh, no, but, so you go 1.07, right?
Yeah.
And then you add another 7 on, right?
Yeah.
So you're gonna add 0.0016 to the 1.07, or probability.
You're going to add
you go to
7.
college, you get this. How much time? Nothing?
It's like 3 minutes.
All right, I will stop here. I will continue with this one. Please remind me.
Okay.
All right? And then I'm going to just say, all right, guys, I want you to work on a couple, and I'll try to walk around everything else. I'm not going to do Poisson distribution as of yet.
Is that French?
Yes. Test is